Hello, and welcome to an AMC 1012 tutorial dealing with stars and bars. Stars and bars is a counting or combinatorics method that tells us how to split n identical objects among k identical bins. So let's imagine we have a row of, I'm going to say, n balls. This is n balls. And we need to split it into k groups, right? So if we have 3 balls, and we need to split it into 2 groups, right? We need to place a line, but only one line, somewhere. It could be there, it could be here, where this side is empty, or it could be here, like this, right? So in order to split a line of n balls into k groups, we need k minus 1 dividers, right? So I could place one here, maybe here, another one here, here, and so on, right? We have k minus 1 dividers, right? And now the problem basically becomes, okay, where can we put these k minus 1 dividers, right? And to answer that, we can use the combinatoric identity n plus k minus 1, choose k minus 1, right? This is a combinatoric identity, right? This will tell us how many ways to order the k minus 1 dividers without repeats, right? Because this is a combinatoric identity, we're not dealing, this is not a permutation over here, that's not a permutation identity, so it comes with no repeats. So let's look at an example to understand what we're talking about here. So let's say I have a line of 6 triangles. So I have 6 triangles here, right? And I want to split these into 4 groups, right? How many ways can I do that, right? N represents the number of items we have in our stars and bars identity up here. So right now, n is 6, right? And we want to split it into 4 groups, right? K in this identity is symbolizing the number of groups that we are going to create. So we have 4 groups, which is k. So we have 4 minus 1, 3 dividers, right? So then, by the stars and bars identity, we would have, right, that we can do this. We can split 6 triangles among 4 groups, and 6 plus 4 minus 1, choose 4 minus 1 ways. And this is equal to 9, choose 3, which is equal to, let's see, 9 times 8 times 7 divided by 6. We have 12 on top. This is equal to 84. So we have 84 ways, right? And that's the answer for that example, right? Let's look at another example, just like that, right? I'm going to say I have 7 balls. It doesn't really matter. 7 balls. Or actually, let's do 8 balls. And I want to split it in 5 groups. How many ways are there to do that? So our n, which is our total number of items, will be n equals 8 because we have 8 balls. And k is our total number of groups. K, how many groups do we want to split this into? We said we want to split this into 5 groups. So our k value is 5. And by the stars and bars identity, we can plug in our answer. So n is 8, n plus k minus 1, which is 8 plus 5 minus 1 over choose k minus 1. So that's 5 minus 1. So that's 12, choose 4. We can do some quick computation here. 12 times 11 times 10 times 9 over 24. This is 120. So 5 here. So it'd be equal to 11 times 5 times 9, which is 495 ways to do that. Now we'll talk about stars and bars with restrictions. Right. We'll talk about stars and bars with restrictions. Okay? So let me give you an example of that. Say we have let's see. Say we have 14 M&Ms. You want to distribute to 7 kids. But each kid gets at least one M&M. Right? Each kid gets at least one M&M. How many ways are there to distribute the 14 M&Ms to the 7 kids? Right? So the number of ways we can do that is, let's see, how would we deal with the restriction? Well, let's call the kids A, B, C, D, E, F, and G for now. So A plus B plus C plus D plus E plus F plus G equals 14. Right? And each of these kids gets at least one M&M. So we can just account for that one M&M right away by subtracting it from the total. So we can make the substitution. I'm going to say A prime is equal to A minus 1, B prime is equal to B minus 1, and so on to F prime is equal to F minus 1. Right, and now we would have the stars and bars equation. A prime plus B prime plus C prime plus D prime plus E prime plus F prime is equal to 7, which is 14 minus 7. Now, we're counting the ways to distribute the 7 extra M&Ms after accounting for the at least one M&M restriction to the 7 kids. Right. We have transformed a more complex problem into a simpler one that we can just apply using the stars and bars identity and find our answer. So our n value is 7. N value is 7. That's the total number of things we have. We have, let's see. Ooh, I forgot the 7th kid. Hold on. G prime. Minus 1. I'll just add it in here. Forgot about the 7th kid. Right? Our k value is 7 because we have 7 kids. Now we could just substitute in our stars and bars identity. 7 plus 7 minus 1, choose 7 minus 1, is equal to 13, choose 6, which would be 13 times 12 times 11 times 10 times 9 times 8 over 6 factorial, which is 720. right? Used to go away. This is equal to 13 times 132 ways we can solve the above problem, the above example. I'm not going to calculate that. You can do that on your own if you want. But we're going to look at one more example of stars and bars with restrictions before we move on. So I'm going to say I have, let's say, 20 M&Ms, right? Instead of 14. I'm going to give it to 4 kids, right? But each kid must get a quantity of M&Ms that is a multiple of 4. Each kid must get a multiple of 4. So how can we do this one? We need to count the number of ways to distribute 20 M&Ms to 4 kids, knowing that each kid must get a multiple of 4. And yes, you can get 0 M&Ms, it's allowed. Right? So we can represent the multiple of 4 condition algebraically. So we can say the first kid gets 4 M&Ms, same for the second kid, and so on. Right? These are the amounts that our kids are going to be getting in terms of multiples of 4. Right? And this is equal to 20. Now the most straightforward thing to do here is to divide this whole equation by 4. So you get a plus b plus c plus d is equal to 5. Now, this has become routine by now, I'm sure, for most of you guys. So we can just plug in our numbers with the stars and bars formula. N is 5. We have 4 groups, or 4 kids in this case. So it will be 5 plus 4 minus 1. Choose 4 minus 1. That'll be 8. Choose 3, which is 56 ways. And that's the answer to our above example. I hope you enjoyed this tutorial on how to use stars and bars for combinatorics and counting problems on exams such as the AMC. If you learned something useful from this tutorial, please share it with those who might find it useful, your friends, family, etc. And please don't forget to subscribe. And I'll see you in the next video. In the meantime, check out this video, or if you have the time, check out that playlist. But don't forget to subscribe.